Thank you very much, and we are back now to continue the phylogenetic analysis from where we stopped. Now we've been able to use Mega to do sequence alignment of 12 sequences that we're interested in constructing a phylogenetic tree for. So now that our alignment has been saved, remember we saved it with SF4 alignment. It has been saved to our desktop. All we need to do now is to fire on to our phylogenetic analysis. Now, so still in our Mega window, the main Mega window now, you will see a tab called Phylogeny. When you click on it, it should show a drop-down menu, and then you should have the option of construct/test neighbor joining tree. You select this option. After selecting this option, it should open a new small window like this, which says choose a data file to analyze. Now you're going to change some configurations. As you can see, our information is on the desktop, and in my own system right now is on C48, a folder called C48. So we have to locate our SF4 alignment file. Now, so I change the folder to desktop, and then you also have to change to all files here because you want to detect all possible files. So when you check to all files, you look for SF4 alignment. You scroll through your desktop and you select SF4 alignment. Hopefully it's not as crowded as mine. And then once you've done that, still in the desktop place, SF4 alignment, and then you click on open. When you click on open, you should have this analysis preference window open shown. Now I usually leave this as a default when I'm constructing phylogenetic tree using neighbor joining algorithm. And then, but one thing of note is that you should note that the number of Bootstrap replication should be 1000. So if it is not 1000, all you need to do is simply click in this box and change it to 1000. And now the necessity of Bootstrap is like you're trying to plot this tree 1000 possible times, so increase the number of randomization, so gives you a higher probability of the fact that everything that is plotted in your phylogenetic tree is actually a true connection. Now you just click compute after that. Now our phylogenetic analysis is in progress. You should have something like this being shown. Then here comes our tree in the new Tree Explorer window. And so we can see our phylogenetic tree. So one thing we can do immediately is to copy the image of our phylogenetic tree. And how do you do this? In the Tree Explorer window, you click on the image tab and you see copy to clipboard. Just select this, click on that, and then paste in Microsoft PowerPoint like I've done, and you can see the tree is pasted in Microsoft PowerPoint. Now we can analyze this tree. We can use it. You could also place in Microsoft Word. Probably you are preparing a report, or you could also paste in your Microsoft Word document for a manuscript that we're preparing. Now from this tree, we can see that SF4 is indeed a strain of Bacillus megatherium because it clusters with the Bacillus megatherium derivatives. Now it clusters with Bacillus megatherium strain ATCC 14581 and NBRC 15308. So these are the closest relative of our Bacillus megatherium. And then to estimate our evolutionary distances, each of this line represents 0.02, and you can see that our tree is rooted to Pseudomonas aeruginosa because it clusters out from the Bacillus group, which is very good for phylogenetic analysis. Now you can save your phylogenetic tree for future references. Now you go back to the Tree Explorer and click on the File tab or menu, and then click on Save Current Session. And then it should open a Save As window. Then you can save it with SF43 like I've chosen to do. You can do same with the name of your choice and simply click on Save. Now in conclusion, I do hope that you have learned how to successfully identify your unknown bacteria by molecular characterization. This is pretty much applicable to other microbes post sequencing of PCR products. Now, in case you're working with yeast and molds, the region of the genome that's usually sequenced for identification purposes is the ITS1 to ITS4. Is the most popular region that is sequenced, and then it is actually subjected to the same analysis that we've discussed. And then you can, one thing that is very different for yeast and molds is that in your NCBI blast during your homology search, you make sure that you select yeast and molds genome for your comparison, because you cannot be comparing the yeast and mold genome to a bacterial 16S RNA. So you select your yeast and mold genome ITS1 to ITS4 in the options that is given to you. That way, and you follow all the other analysis method that we've done for the phylogenetic analysis and the sequence alignment, and you should be fine. So I'm very grateful for your time. Thank you for listening. So right now we'll proceed to the hands-on of the phylogenetic analysis. Thank you very much.